Welcome to Properties of Water. Some of these properties you already know that you've learned throughout the whole entire year in chemistry. Others are going to be new to you guys. The first property we're going to talk about is that water is electrically polar. You've heard the terms polar and nonpolar before, and hopefully you remember that the term polar means charges. Water specifically, though, has an uneven distribution of electrical charges. So if we take a look at the water molecule down here, we see that oxygen has a slightly negative charge and hydrogen has a slightly positive charge. So this is kind of an unequal distribution. You know, we've got the one oxygen here, but we have the two hydrogens here. And a good way to remember polar is it has to do with the poles, our north and south poles, so it's got that charge to it. When we relate that polarity of water back to itself, we can talk about, well, so what is so unique then about water and its polarity? We see that water molecules like to attract to one another, or they like to attract to ionic compounds. And if you recall, ionic compounds are compounds that have charges to it. So if we take a look at this picture right here, we've got our water molecule, our H, our 2, and our O, and then we have a sodium and a chloride molecule. And so that was a salt molecule. You can see that they're stuck together. Both of these are attracted to one another because they have charges. And what is so unique about these charges is you can see that this oxygen molecule that has a negative charge likes to attract to that sodium molecule that has a positive charge. On the other side, the positive hydrogens attract to the negative chlorine. What this allows water to do is it allows it to make it possible for it to dissolve lots of different things. So these water molecules will pull this sodium chloride apart and it will dissolve that salt in solution. So we like to call water the universal solvent. It basically will dissolve just about anything, which is extremely important for our bodies, especially if you're taking medications that need to be dissolved in your body. Your body will break those medications down and distribute them to where they need to go in your body. So in addition to water being polar, we can talk about nonpolar compounds as well. And if you remember, nonpolar compounds are those that do not have a charge to it. So they don't have a positive or negative end. And if we take a look at these two pictures right here, we've got my water, which is my polar molecule. It has as its charge. And ethane is nonpolar. There's no charges with it. So if we said previously that water likes to dissolve in polar compounds, do you think water, which is polar, and ethane, which is nonpolar, are going to dissolve in one another? The answer should be no, because nonpolar only likes to stick with nonpolar, and polar likes to dissolve in polar. So we have a rule, and that general rule is that like dissolves like. Water and ethane do not mix. It's kind of like water and oil. Oil is nonpolar, water is polar. They are not alike, therefore they will not dissolve in one another. Our final concept when we're learning about properties of water is the three terms solution, solute, and solvent. Solutions we were introduced to back when we talked about mixtures. Solutions is a mixture formed when a substance dissolves in it. So you encounter lots of solutions in your everyday life. If you were to have a can of pop, for example, that is a solution. If you were to have sugar water or salt water, that is a solution. We can break down that solution into two parts. The first part is called the solute. The solute is the substance typically found in smaller amounts that is able to dissolve. So it fully goes away and dissolves. What it dissolves into is what we call a solvent. The solvent is the liquid portion of the solution, and it's generally in higher concentration. So this example down below, sugar plus water, those two combine together to form a sugar-water solution. So if we look back at our definitions and what we just learned, we need to identify whether sugar or water is going to be the solute. Which one dissolves in the other? If you guessed that the sugar was the solute, you are correct, which leaves the water, the liquid portion of it, to be the solvent. So the solute dissolves in the solvent and it forms my solution, which is a sugar water solution. Finally, we're going to watch this short video clip about more properties of water. Again, some will be new to you, some will be repetitive to you. There are questions throughout the video that you'll find in your notes that you need to answer, or you can wait until the end and try and answer them there.
It might just be the most universally known fact in chemistry, the chemical formula for water, H2O. A model of H2O doesn't look like much. Two small atoms of hydrogen, the H2 part of H2O, attached to one bigger atom of oxygen, the O part of H2O. Kind of like a cartoon drawing of a teddy bear. And actually, water is kind of funny. Fun facts. Water, H2O, is the only natural substance on Earth found in all three common states of matter: liquid, solid, and gas or vapor. It's also one of the only common substances that is less dense in solid form than in liquid form. And water can dissolve more substances than any other liquid. Let's focus on H2O in liquid form. What gives water its remarkable qualities and abilities? It's all in the molecule's content and structure. Not just what each H2O molecule is made of, but how the atoms are positioned, in what configuration and shape, and how they are bound together. In water, just so you'll know for later, the H's and O's are held together by covalent bonds, by sharing electrons. H2O is a polar molecule. The same way our planet has north and south poles on opposite sides, the H2O molecule has two poles on opposite sides. And like a magnet, H2O has one positive end and one negative end. Thinking of that cartoon teddy bear again, the chin side of the oxygen atom has a slight negative electrical charge. The opposite side, the side with the two hydrogen ears, has a slight positive electrical charge. This might just be the second most universally known bit of chemistry. Opposites attract. The positive hydrogen side of every H2O molecule is going to attract and be attracted to the negative oxygen sides of other nearby H2O molecules in all directions. More and more of them pull closer and closer together until they're like people in a hot, crowded dance club. Packed so close together they can hardly move, but still turning and moving wildly. Molecules that stay close to each other are called cohesive, and water is highly cohesive. Septillions, octillions of chaotically moving, tightly packed H2O molecules cohere to make a single raindrop. As good as water molecules are at all this cohering and convening, they also form bonds with surfaces and molecules unlike themselves, a force called adhesion, as in adhesive. Pour the water out of a glass, and the inside of the glass is still wet. Some H2O molecules stick or adhere to the silica molecules in the glass. Being cohesive and adhesive is what makes water a near universal solvent. How? Take salt or sodium chloride, sodium ions, abbreviated as Na+, and chloride ions, abbreviated as Cl-, in a crystal. As soon as a salt crystal hits the water, it's rushed by a molecular mob of H2O molecules that break it apart, separate the sodium and chloride ions, kind of a chemical divide and conquer. Because sodium ions have a positive charge, each one is swarmed by H2O molecules flying at it with their negatively charged oxygen sides, completely surrounding the sodium ion, isolating it, carrying it off in a turbulent sea of H2O molecules. The same thing happens in reverse to the chloride ions, which have a negative charge. Each of those is surrounded and isolated by H2O molecules leading with their positively charged hydrogen sides. Each salt crystal is broken into tiny pieces, dissolved by and into the water. There's much, much more to know about H2O and how it works to keep every living thing on the planet, and maybe other planets, alive. Think of this video as a drop in the bucket.